Hi, Algebra 2. I'm going to give you some notes over simplifying, multiplying, well, just multiplying in this video, rational expressions. And this is the first part of concept 39. So let's look at some things here. A rational expression is a fraction whose numerator and denominator are non-zero polynomials. The domain of a rational expression excludes values that make the denominator zero. As always, we don't want that to be the case. A rational expression is in simplified form when its numerator and denominator have no common factors. So that's going to be the name of the game today, is to simplify after we do anything else we're asked to do. So look at the core concept. So we have this property, AC over B, I don't know, is that an E? I think it is, okay? And then if you look to the right, that is after, no, I'm sorry, it's BC. Then after the C's have been divided out, what we're left with on the right side of the equal sign is A over B. So from the left to the right side of the equal sign, that expression has been simplified. Now look at the example, so 15/65. So to the right side of the equal sign, then see that 15 and 65 have been rewritten in their factors, and then that common factor of 5 has been divided out. So our final simplified form of that fraction is 3/13. You can do the same thing with expressions that have polynomials. So look at the one just below. We've got 4 times the quantity x plus 3, all divided by x plus 3 times another x plus 3. So we can divide out one of those x plus 3 pairs. And what we're left with is 4 over x plus 3. So that is a simplified rational expression. When you simplify rationals, you have two steps. The first is you're going to factor the numerator and the denominator if you can. The second is you're going to divide out any factors. So if you look at the example below, I have written first under the first step where both of those have been factored. And then the second step, you can see that one common pair of x's has been divided out. Now look over to the left at the study tip. So you can divide out common factors in the second expression in the right, but you can't divide out common expressions or factors in that third expression. So x plus 7 and x. Because when you have an expression where things are added or subtracted together, you can't divide out from one of them separately. It has to be together. Now let's look at example 1. So the first thing we're going to do is factor our numerator and denominator if we can. So we have a quadratic. I'm looking for two numbers that'll multiply to give me -12 and add to give me -4. So we know that that's -6 and +2, so that will factor as x minus 6 times x plus 2. Hopefully you remember in the denominator we have a difference of squares, and that will factor as x plus 2 times x minus 2. Now we can divide out any common factors, and I see 1 and x plus 2. We can't divide out terms separately if they are connected with an addition or subtraction. So x minus 6 over x minus 2 is our final answer. We are not able to divide down any further because x minus 6 is its own term and x minus 2 is its own term. What we can do now is give a domain rule. So we're going to look at the factored originals, the step just above, and see what would make the denominator 0. Well, we can tell that if we have a -2 or a +2 in for x, that would make our denominator 0. So that's our domain exclusions. All right, let's move on to our next couple examples. So number 1, that has already been factored for us. So we can just go to dividing out common terms. And I see 1, the x plus 1. So we'll divide that out, and what we have left is 2 over x plus 3. Now let's give our domain rule. So we're looking at the step above before we divide it out. So the numbers that will make that denominator 0 would be -1 in for x and -3. Now number 2, we do have some factoring to do. Not in our numerator, but our denominator is a difference of squares. So it'll factor as x plus 4 times x minus 4. Then we can divide out our common term. Now remember, anything divided by itself is 1. So I'll have a 1 in my numerator over x minus 4. And then I'll look at the step before I simplified, and my domain exclusions are -4 and +4. Now, sometimes you'll have an expression that's simplified. So everything's been factored. There are no common terms or common factors, except for one. So all we're going to do is make note that it's simplified and then give a domain rule. So our domain, we have to exclude 0, because if I plug in 0 for that single x, it would multiply by whatever comes next to it and make the denominator 0 and -2. All right, now number 4, hopefully you recognize that we need to factor both numerator and denominator if possible. So two numbers that multiply to give us -3 and add to give us -2, which is -3 and 1. And then two numbers that multiply to give us -6 and combine to give us -3, which is -3 and 2. So now let's divide out our common factors, which is the x minus 3. I can drop the parentheses around my numerator and denominator because I don't have anything that I'm separating them, dividing them off of a multiplier. So that's my final answer. And for my domain rule, I look at the step above before I simplified, and I have to exclude 3 and -2. All right, let's do some more practicing. Actually, now we're going to multiply rational expressions and then simplify. So a moment ago, we were just simplifying. Now we're going to multiply. Now, when you multiply a rational expression, it's the same as multiplying a fraction. You just multiply straight across, numerators together and denominators together. And then you simplify, just like we were doing. So look at that example down below. The 5x squared over 2xy squared times 6xy cubed over 10y. So that's our problem. Now the next step is the thing you see to the right of the equal sign, that's when the multiplying has occurred straight across. So we get 30x cubed y cubed over 20xy cubed. Now, to the right of the equal sign is when common factors were divided out. So we can divide both top and bottom by 10, and we get 3 over 2. We can divide out those y's and divide down those x's. Now, when we give our domain rule, notice we have to look back at the step before we simplified, where there was both an x and a y in the denominator. So we have to say that our denominator x cannot equal 0 and y cannot equal 0. All right, so now let's try. Oh, I've jumped right in. So with these, I'm just going to multiply straight across. So I get 56 x to the 7th. Remember to add your exponents, y to the 4th. And then 8x y to the 3rd power. Now I can divide out common terms. So I'll get 56 divided by 8, which is 7. X to the 7th divided by a single x is just x to the 6th, and then y to the 1st power, all over 1. So I don't need to write that as a fraction. And then I need to exclude for my domain that x cannot equal 0 and y cannot equal 0. Example 3, we've got some factoring to do before we multiply. So I'm going to factor out a 3x, and then I'm going to do my trinomial factoring, so -1 and 5. And then in my second term, I'm going to do some trinomial factoring, so -4 and +5, all over 3x. Now, here's something you can do when you have more complex multiplication problems. Before you multiply, you can divide out any numerator with any denominator. And that just helps simplify the problem, and you don't have to write, kind of repeated expressions. So I'm going to look at numerators and denominators. I notice that I can divide out my 3x's, and I'll get a 1 in that denominator down there. I notice I can divide out my x minus 1's and then my x plus 5. So I'm looking for a numerator to divide out with a denominator. So what I have left is just x minus 4 over 1. And so I can write that as x minus 4. Now for my domain rule, I need to go to the step above my simplified version and make sure that I exclude anything that'll make the denominator expression 0. So 1, -5, and 0 would all do that. Okay, and remember as you're taking notes, you pause the video because I'm going pretty quick here, and then so that you can get everything that's covered. All right, now I've put a more complex, challenging problem. So notice in our first expression, x plus 2 is it doesn't have any factoring, but we have a difference of cubes. Do you remember that factoring pattern? I will write it down for you, and you'll want to get that down. So remember, a sum of two cubes is almost the same, except for the sign in the first expression is positive and the first sign in the second expression is negative. Now let's factor. So we get x plus 2 over x minus 3 times x squared plus 3x plus 9. Now our second expression, we can make that into a rational by putting it over 1. And it just so happens we get to divide out those big ugly trinomials there. So what we're left with is x plus 2 over x minus 3. Okay, now for the domain rule, we're looking at the expression above before we simplified. So we have to exclude 3. Now we're going to take that ugly trinomial, set it equal to 0. It will not factor for us, so we're going to solve using the quadratic formula. Notice I've picked out a, b, and c. So here we go. The opposite of b plus or minus b squared minus 4ac, all divided by 2a. And we are going to have an imaginary number. So we're going to exclude negative 3 plus and minus 3i times the square root of 3 over 2. We're going to do another one like this in the notes. I do want to say just that when you get into the practice, you will not have any non-real exclusions. But I do want to expose you to this because that can be a possibility. All right, so let's do some of these practice problems. I'm just going to multiply straight across numerators and denominators first and then simplify. All right, now we're going to simplify our numbers, so that reduces to 1/4. And then our x terms, which 6 minus 2 is 2, and then our y's, 4 minus 2 is 2. Domain rule, I have to look at the step above and make sure that I say x and y cannot equal 0. All right, number 6, do you see that we've got some factoring to do? So let's factor out a 2x, and then x plus 5 times x minus 5. And then our second expression doesn't have any factoring we need to do. Now we can divide out any numerator with any denominator before we multiply. That's just something we can always do. So we're going to divide out a 2x, and we have one x left in the denominator and an x minus 5. So our simplified expression is x plus 3 over x times x plus 5. And then we have to exclude from the step above negative 5, 5, and 0. All right, number 7. So do you see I have a difference of 2 cubes again? So let's do that factoring. So x minus 1 times x squared plus 1x plus 1. And then times, we'll just make that into a rational by putting it over 1. We get to divide out those trinomial expressions, and we're left with x plus 5 over x minus 1. So of course we have to exclude the 1, and now we're going to use the quadratic formula to solve, knowing that we're going to get a non-real answer, and we'll exclude that. So just a reminder that there will be no non-real exclusions when you're working on the practice. But, you know, if one did show up, which it won't, but if it did, you would be able to handle it. All right, that concludes our notes, and we will pick up dividing rationals when I see you tomorrow.